Show of hands, who knows what fourth is? Wow, that's a very rare audience, right? So I've been kind of weirdly fascinated by fourth for some time now. It's a programming language. It's an interpreted, kind of semi-compiled programming language that looks like this. Kind of looks like nothing you'd ever want to use in everyday programming, but you can do some really weird stuff because, you know, kind of like Lisp, you can modify it and do all sorts of stuff. Now, how does it typically get implemented? It's generally a list of words that people mostly implement as a linked list. So very simple, you just need an extra pointer besides the data. The words are code fragments. You'll see what I mean in Zig in a second. And then you have a threaded interpreter to jump around them. So the interpreted nature of the language. And this is real code. And, you know, of course, 42 is the answer. So this is actually some ASCII diagram in some interesting x86 literate program code called JonesForth. So Richard W.M. Jones, the guy who just recently made the news again for discovering the XZ hack. You guys hear about that? This the XZ exploit, and he was the Red Hat engineer who noticed some microsecond latency and was like, wait, this is weird, and saved us all from, you know, doom and horror. So he wrote this in ASCII. I used some program I found online called SVG Bob to turn it to something kind of nicer. So really, this is in assembly. This is what it looks like, where you have these collections of zones of area of memory, which lots of pointers, and then because this is actually indirect trading, it's pointers to instructions. It's a bit hard to get your head around. So when he wrote this in assembly, that's what it looked like, right? This is a magical x86 instruction that loads IP into AX and increments IP. And so when I did a first translation of it in C, I used goto and computed goto at that, which is, you know, the stuff they tell you not to do in class. But when you're just fucking around, it's fun. And then I said, oh, but wait, Clang offers this weird thing called mustail, which means you write functions, but you never call them, you jump into them. You never push anything on the stack. And I was like, oh, this is really neat. It makes my code slightly less disgusting. And that's when I said, oh, by the way, now that I kind of explored the space in C, I wonder if there's another programming language out there who would let me do that. So like everybody else, because I'm sort of a cargo code programmer, I looked into Rust. Rust does not support mustail, and they have no plan to support it, but Zig does. Yay for Zig. And so basically, just this little trick allowed me to rewrite this whole thing in Zig. I don't know if it's idiomatic Zig, because it's the first Zig I ever wrote, but it all works, and, you know, Zig lets you do it. I did have to fight a little bit, because in order to support some of the more advanced features of that air quote language, you want everything to be fully contiguous in memory, right? You want to use what C, you know, modern C calls VLA, variable length arrays, or flexible array members, which Zig supports when you do a C translation, right? So at the ABI level, it supports it. I really tried hard to do it in Zig with the few examples I could find, and I ended up just not making it work. Because really, what I want is, right? I have this structure here, which represents my word. Remember, I said it's a linked list, so it has a link to the previous word. It has a flag. It has a name, which allows the interpreter to map what you type to the address of the function you mean to call, right? And then you have this collection of functions, instructions, which it's a union. But this will be somewhere else, right? You'll have these few words next to each other in memory, and then you'll have a pointer to another place that contains it. I need it all packed together. And what I ended up finding that works is just flip this around in your head and think, well, this is really what I want is just an array of instructions. And these first few bits of it, I'm going to do an incast of to reinterpret like this.
An incast?
At intcast.
Oh, intcast.
Yes. So really instead, right, I do all my, I'm sorry, I tried with incast because whoever very gracefully responded to my question on Discord suggested incast, but no, I had to do a pointer cast. So this is actually what my code looks like, which is a bit weird. It feels like I'm abusing the rules of the language, but it works, right? And it not only does it works kind of fast. So I put together a little bit of code to calculate the largest Fibonacci number you can represent in 64 bits. And I have 3 flavors of it. I have a Python flavor because, Python is getting faster. It's a good language. It's also what I do all day, every day at work. It's what I did all day, every day at work when I was working. I'm currently on a non-compete, so I'm doing nothing, which is wonderful. So, Python takes on average almost 60 milliseconds to calculate a single Fibonacci number, which has, 20 digits. So my little code here does it in 3 milliseconds, which is less than 60. But then, of course, if you write the whole thing in Zig itself and you compile it using optimization and everything, Zig still kicks my ass because, I'm not a professional programmer. And, this is the original code that kind of got me falling into this rabbit hole. If you want to learn more about Zorth, you can go look at that. And then here, let me take us down the shameless plug for a second. Will this work? Yes. So I have a blog where I just nerd out on these things. And one thing I have not yet done with the Zig implementation, but I want to do it. So I talk about the various iteration of it. So if we go to this one, and I know I can do it with Zig, but I'm finding the build a little bit. Then you can do stuff like this. And you can say, as I said, right, it's fully introspectable. So there's a word called quit, and you say, hey, I'd like to know how quit is implemented. And this is quit. And then you can implement, double, which is dup plus blah. And I can say, hey, I forgot how I implemented double. Please show me how I implemented double. And this actually, it hasn't kept track of the textual representation. It has a bunch of memory addresses and links between them. But the interpreter, which is only a couple hundred lines of Zig, is smart enough to perform introspection on itself. It's kind of fun. It's completely useless. Don't ever try anything like that in production. Also, it only supports int and strings by abusing ints. So it's a massive hack, but it's fun. Any questions?
I'll let somebody.
Oh no, I'm good. I was just gonna start uploading.
The must tail call or whatever that thing called, that doesn't move the stack pointer, right?
No.
So do you have to be like really defensive about how you're not clobbering the stack? And
You're not using the stack.
You're not using it. So
you're just jumping around memory. That's all you're doing. As a consequence, since this thing has a notion, so these words are kind of like functions that don't take any parameters because all they do is operate on. So Zig actually has 2 stacks. It has a value stack where you push numbers and pop numbers, and then it has a return address stack. And actually, real proper production Zorth have a 3rd stack, which is a floating point stack, because this language is so old. When it started, floating points didn't even really exist. Who needs floating points? They're just bytes, right? So, anything else? Awesome.